Lesson 17, solving equations and inequalities with absolute value.
Well, wait, 1 second. Wait, I have a question.
Mm-hmm.
So you never answered my question, on 7.
Because I said put a question mark by it.
No, I have a question about how you got your answer. Because
Oh.
I thought it's only not a function if 2 x's get the same y.
And 2 x's do get the same y 3 times. 3 x's got this, wait, no.
Oh, we'll talk about that after this lesson.
Okay. You're not recording.
Okay, so if the absolute value of x minus a and your absolute value equals k, and of course k has to be greater than or equal to 0 because it's absolute value, x minus a can equal k, or x minus a can equal negative k. So if you put in negative k in the absolute value will be equal to k. So we can have what's inside the absolute value be equal to the positive or negative answer. So one thing you want to do, whoops, that was supposed to be a star, is check for extraneous solutions. An extraneous solution, that's a C, is just a solution that doesn't work when you plug it back in. So I'm going to give you some examples. The absolute value of 3x plus 18 equals 6x. So we can say that 3x plus 18 equals 6x, or 3x plus 18 equals negative 6x. And then we solve for x. Here we're going to subtract 3x and get 3x equals 18. And so x equals 6. And here we'll add 6x and subtract the 18. So 9x equals negative 18. X can be negative 2. And then we're going to check both of our answers to see if it works. So the absolute value of 3 times 6 plus 18, does that equal 6 times 6? Yes, because 18 plus 18 is 36. So that works. Yes. And then we'll do 3 times negative 2 plus 18. Does that equal 6 times negative 2? So negative 6 plus 18 is 12.
That's negative 12.
Wait, that doesn't work because that would be a negative 12. So this is an extraneous solution and it won't work because the absolute value has to be positive. Kenna?
So how did you get from the 3x plus 18 equals 6x to just 3x equals 18? Oh, like one of them.
Oh, I subtracted 3x from this side and then I used the the
I was doing
symmetric
like,
property.
6x from both sides and I was like super confused and I was like, it should be negative. Okay.
Oh, yeah, then they both would be negative. Tan?
So the equation says x minus a. So shouldn't it x
Oh, it doesn't.
3x? It doesn't matter.
No, it's whatever's in there.
Okay. Put plus one.
So for inequalities, so that was if it was equal. For inequalities, if it's less than or equal to a number k, and again, k has to be greater than or equal to 0, then you have a conjunction. This is an and statement. A conjunction. So we have negative k will be less than or equal to x minus a, which has to be less than or equal to positive k.
Okay.
So if you think about absolute value as a distance from 0, if the distance is less than a number, then we're talking between the negative and the positive of that number, because we're talking about the distance from 0. So for instance, if the distance is less than or equal to 3, then we're looking on the number line from negative 3 to 3. That distance, all that distance within there will be less than or equal to 3 from 0, like the distance from 0. So it's an or statement. I mean an and statement. Sorry. That's what I meant. Jasmine.
Will we ever have to like the graph that equals k? And if we do, how do we have to do that?
If
Yeah, 'cause like,
with an equal sign,
yeah.
it would not, it's not an inequality, so it would probably just be a point. No, usually we don't graph those ones. Now if it's greater than or equal to a number, and again, k is greater than or equal to 0, always. Now this is an or statement, because we're talking about distance from 0 greater than a number. So we're going to have x minus a is greater than or equal to k, or x minus a is less than or equal to negative k. This is called a disjunction. Ouch. It's an or statement. Now, some things you want to look for is if you have the absolute value of x is less than a negative k. Remember, k is positive because or 0. It's greater than or equal to 0. So if you have the absolute value less than a negative number, then there's no solution. Because absolute values are always positive. Now, if you have the absolute value is greater than a negative number, then the answer is all real numbers. Because absolute value is always greater than a negative number.
Oh yeah. I was just thinking of like if it was like a negative 2 or something or negative 1.
So a parent function is f of x equals the absolute value of x.
This is Tan's function. Huh? It's your function. Parent function.
No, the tangent of x is tan's function.
I just got 2 functions.
So the parent function looks like this. So the y values, the domain is all positive numbers. No, the range, sorry. The y values is the range, is all positive numbers. And the domain is all real numbers. So it just looks like a V. And the right half of the V has a slope of 1, and the left half will have a slope of negative 1. So if you can transform, you can go through the rest of my transformation. Oh, it can go through transformations by changing the parent function. So if I did a negative absolute value of x, then it reflects in the x-axis. So we just want it then negative. Well, I guess that's reflecting on the x-axis.
How would you turn it like 90 degrees?
It's a x equals f of x equals absolute value of y. Yeah. So the changes can make it skinnier, fatter, raise it, lower it, move it to the right or the left.
Yeah, how do we do all that?
Just depends. Say what?
How do we, like, if, like, the slopes change, or, like, if it moves left to right or up or down, what will it show on the,
Oh, it depends on, for instance, left and right is what's inside the absolute value. Skinnier or fatter is what's on the outside, because that's just changes the slope on each side. Up or down is when you add on the end a number.
isn't
Like if
it
you
like
add
where
two,
you
you go up
add,
to.
like, say you have, like, absolute value of x plus 3, wouldn't you be moving it to the left 3?
Yes, if it said absolute value of x plus 3, it moves to the left 3. If it was minus 3, it moved to the right. But on the end, if it's plus, it goes up, and if it's minus, it goes down. We are going to do the lesson practice,
that
but
will-
I'm ending this film now.